In this video, we're going to determine the timing relationship between the crankshaft sensor missing pulses time and the cylinder 1 firing time. Notice that the time base is set for 200 milliseconds, which forces streaming mode and creates a large capture file on the computer so we can zoom in later to look at details. I made a single channel coil-on-plug adapter so that I could measure my 4-wire ignition coils. Notice there's a quarter soldered to the end of the center conductor, and there's a grounding strap on the shielding. It also has a 20 dB attenuator, which is required. I also made a 3-cylinder paddle so I could check all 4 cylinders at the same time by using the 1-cylinder paddle and the 3-cylinder paddles together. The cam sensor connector is located on a pigtail because you can't even see the cam sensor. So it's located right here, and we'll zoom in and give you a better view of it. So this is where we connected the cam sensor. And also on the top of the engine, on the driver's side is cylinder number 1 ignition coil. So we connected the paddle to cylinder number 1 ignition coil. With the streaming capture, I can easily zoom in at 1 level and then zoom in even deeper at a 2nd level and get all the detail I need to measure the signal. As it turns out, there's 60 pulse locations per crankshaft revolution, and 2 pulses are missing for sync. And it also turns out that 21 pulses after the sync pulse is when the number 1 cylinder fires. With the engine hot and idling, notice there's also an additional 280 microsecond delay after the 21st pulse. This is primarily because the scan tool says that at hot idle, the timing is -2 to -4 degrees. And so this extra delay in the ignition is why it's a little bit past, I believe. If there's 0 timing delay, I think would fall right on the 21st pulse. But that's something you can decide for yourself. Anyway, we've achieved our objective. We know that 21 pulses after sync time is when cylinder number 1 fires. And that pretty much concludes this video.